Okay, look up, please. Everybody look at me. Okay, there's actually no homework tonight. We're starting, this happens pretty routinely in this class because we have to focus on big ideas, not on small tasks. So we've spent the first 4 homework packets focusing on limits and discontinuities and things that are associated with those. We're switching completely now, and then we'll show how it ties together at some point. But so this packet is an introduction to some new ideas. So don't do it as homework. We're just going to start working on it today. The timing is actually quite convenient with the Labor Day weekend. It's kind of nice to have a weekend without homework, so don't worry about that. What I'd like you to do first is we are learning some things about the calculator today. I want you to put these 3 formulas in your calculator, so go ahead and do that. And then see if you can get this to appear. I'll just walk the room. If you need help, just stop me. So go.
You click y equals.
Uh-huh. As you're typing, you just X and then use the caret.
Okay. I was using that. I was just making sure.
Yeah, no, you don't need to use parentheses.
What's the window you're using?
Somebody pause for a minute. Look at me. No one talk. Everybody look up. Everybody put your calculator down. Look at me for a moment. So just gotta make sure you're looking at me so you hear this. Call and look up for just a second. Okay, I'm going to show you a feature that for AP Calculus is extremely useful, and it's not a feature that is commonly used in previous classes because it just hasn't been needed, but you'll use this one a lot. It relates to Jonah's question, 2 points for asking. For AP Calculus questions, it is extremely common for them to either give you a picture like you see on the worksheet here, or in the text description of the problem, they'll describe what X do we start with, what X do we end with? Or in this case, time. What time do we begin with, what time do we end with? And so I would look at the worksheet, and I notice that this graph is starting at about time equal -2, and going to time equals 7. Again, don't get confused. On the paper, we're talking about x of t, which is position. So that's the y-coordinate of this blue graph, x of t. Time is the x-coordinate. But on the calculator, we call this x, and we're calling this y1. Like that. Warning. Look at me. Anyone who missed this one, Allie, look up for just a second. On the AP test, on the written section, you are not allowed to use the notation y1. I don't really know why they have such a hang up with that, but they actually will not give you any credit if you use that. You have to use the notation x of t. So even though in your calculator it is in y1, you can't write that down as like your solution. You can make a little note off to the side to just remind yourself, but it's not part of your solution. Question? Okay, back to the window. So what you're going to do to get the right window is you get everything entered, just press the window key, choose x min, which again, this is time in our example. So the minimum time is -2. The maximum time is 7. Don't change anything else. Let the calculator do that automatically. So I get those entered, then I hit the zoom key, and the feature I want is called zoom fit. It's like 9 keystrokes down the page, so I hate hitting the down key that many times, so I just press 0. So zoom 0 is what I want. and then the window will adjust automatically. Johnny, you are needed for 5 minutes.
No.
Your girlfriend. What?
I just wave. Can you show it again? Just wave at me. Can you show it again? So just so basically, you're gonna look at the problem. Hey, this will happen over and over again. Like it happens on many, many problems once we start using the calculator. So you look at the problem, figure out what the window should be, but don't pay attention to the vertical, only the horizontal. So I'm going to start at time equal -2. I'm going to go to time equals 7. So in my calculator, I hit window, and that's what I specified, -2 to 7. Then it's zoom, nothing else, just those first two. Zoom 0 or zoom fit. Just go like this. Can you show it again? You would not get it to work. Score. Cool. Just let it finish here for a second. Oh, here's a feature. Oh yeah, Thomas.
The yellow background.
The gold one.
Yeah, sorry.
Sure, I didn't get to you. Sorry about that.
No, it's I'm dropped.
That distracted somehow. Oh, that's right. You still got it. That's right. You up? Okay. I forgot to mention a feature that can be useful. Look at me. Once in a while, you're working an AP problem. If it's in the middle of the test, it is timed, and so you're not trying to hurry, but you don't want to waste time. I have to change the window to make this demonstration work. So I go zoom fit, and let's pretend that right away I notice something is wrong. You've probably had that happen. And you don't want to sit and wait. You're like, oh dang it, I did something wrong. You don't have to wait for the graph to finish graphing. You can stop it immediately by pressing the on key. My screen's a little slow, but it'll stop here in a second. And then fix whatever's wrong and do it again. Questions? We go back to window, -2, zoom fit. Okay. Questions from anyone? Awesome. So let that scroll here. Let's go back to the notes. Okay, big idea. This graph is showing 3 different plots. It's plotting the velocity, the position, the velocity, and the acceleration. You want to put in your packet that when we talk about position, so position is x of t. All year long, I'm going to refer to that as an amount. Okay? It's an amount because it only describes, how many meters. The units are just meters. So that's an amount. On the AP test, they have many, many questions where one of the things they're describing is an amount. Here it's an amount of meters, like a number of meters. I've seen, I don't know, tons of gravel, the level of water in a tank, the temperature of something. But basically, don't forget the word amount. That's going to continue to show up. Then they'll describe the rate at which that amount changes. In our example, that rate is velocity. So that's v of t. So v of t is the rate at which the amount is changing. In this case, meters per second are the units. And then The third thing they describe is the rate at which the rate itself changes. So I abbreviate that as just RR, the rate of the rate. And in this example, that's called acceleration. And this would be meters per second every second, like that. You should see the pattern. The first column is simply meters. The second column is meters per second. This third column is meters per second per second. That's the evolution for every AP problem we'll work on that's, follows this similar pattern. Amount, rate, rate of the rate. So, question? Please.
Sorry, what is another name for rate of rate? Like it was
Oh,
just drawing a blank on what it was.
you're fine. In this particular example, the rate of the rate is also known as the acceleration.
Oh, okay.
Perfect. 2 points for Cameron. Anyone else? Awesome. Abbreviations, of course. This one's just M for meters. Second one, M meters per second. Third one over, meters per second squared. So put a C there. Like that. Questions? Cool. Okay, next thing to make sure you're understanding. We talked about from the very beginning of class that when you look at a graph, you're just looking at a bunch of dots, infinite number. Every dot has two numbers associated with it. For example, let's go just kind of randomly to right here. Time equal 3, and focus on that dot. So that dot has an x-coordinate of 3 and a y-coordinate of about 60, 70, hold on, it's 20, come on brain. So it's about 75 negative. Okay? The two numbers represent something about this particle, because this graph is talking about a particle moving along an x-axis. Here's something that messes people up. The particle is not moving along this x-axis. That's not what they're saying. They're saying the particle is somewhere else. It's moving along some other line. So here's the line along which the particle is moving. This x-axis, this horizontal line. The particle is not up here. This is simply a graph showing information about the particle. But the particle is nowhere to be seen in the graph. Question? Oh, please.
Can you explain that?
So as I read the problem, 2 points for Caleb. It says from time 0 to time 7 seconds. So they're just giving you this window of time where they observe something. A particle moves along the x-axis. I don't like how they say it, but that's how they say it. It's not this x-axis that the particle is moving along, because this is just a bunch of numbers. There's no particle here, just numbers. The particle's over here, moving along this line. That's what the statement is saying to you, is you should think of the particle as being somewhere else, moving back and forth. It doesn't move up and down and back and forth, just back and forth. I'm not sure that helps.
I feel like it needs to be
You're good. Tommy.
I don't know. I'm just having like a difficult time like understanding exactly why like over there is the x-axis but not on the graph. Like like maybe I'll just get it like a second note.
No, you're asking a very normal question.
I'm just confused like why the particle only moves left to right even though like the lines go.
Oh, but 2 points. I wish they would use different words. They just don't. So we have to get used to their wording. Like I would prefer that they would say this, Thomas. From time equals 0 to 7 seconds, a particle moves along a horizontal line. They're like, oh, here's a horizontal line.
So are you basically saying you're just really what matters is along the horizontal line, like for a value of y, then you get x, or is it the other way around?
Let's keep going for a second.
Okay.
Somebody else had their hand up. Yeah, please.
The graph is just displacement over time, right?
Yep.
Okay.
Yeah, position. Gotta be careful. Displacement is different. It's not exactly the same thing as position, so I don't want to say it's a graph of displacement. But you're on the right track. So, 2 more. Let's go here. This will, I think, address what's being asked. You need to memorize a word. The word is origin. And unfortunately, the word has a double meaning, and you just have to keep track of which meaning we're referring to based on the context of the problem. So this graph has an origin right here. Okay, that's the origin of the graph. But the particle's motion also has an origin. And origin doesn't mean original. Origin simply means a reference point of 0. So that's this line along which the particle moves. The origin of that movement is not where the particle starts, necessarily. It could start here. It's not necessarily where the particle starts. It's just, think of it as just the center of the line. Okay, so memorize the word origin. It's going to show up in a lot of problems. Let's go back to this number. This, I think, will answer. Again, every time I say your name, make sure you mark down a tally mark. So, Thomas and Kayla asked the question. Here I think this will help. This is just a bunch of dots. The 3 means time. So the 3 means that 3 seconds into this 7-second journey of the particle is located at a position 75 meters from the origin. Negative means to the left, your left. So over here, this is where the particle is actually moving. I can say, okay, got it. Right here, we'll say that's 75 meters from the origin. That's where the particle is at time 3. So this blue graph goes up and down. The particle does not go up and down. The particle goes back and forth. That helps, right?
Yes, yeah.
Yeah. You don't look at the graph and see the particle in the graph.
Okay, yeah, no.
It's
that makes
not
sense.
there. Is that better?
Yes, yes.
Please. There.
How do you figure out which ones are like which equation of the line?
Awesome. You can remember some characteristics that you've learned previously, but if you've forgotten, it's okay, don't stress about it. Just grab your calculator, hit trace, and the calculator will show which curve it's highlighting. And so I can move the cursor enough so I can go, oh, okay, got it now. That blue one is my first formula or position. The up and down arrow will move the cursor to the other graphs. Does that answer your question?
Yes.
2 points.
Thank you.
Anybody else? Sweet. So back to here. Okay. So the 3, negative 75 simply means time equal 3. This is where the particle is located along this horizontal line. Cameron, please.
Let's say it was at 7, and let's just say 10 for a number. On that purple line, so would it just be ahead, but like, and you just say it was ahead by 10?
Uh-huh. Yeah, in fact, on the purple line, it's a little tricky to try and describe time, because this is really where the particle is moving. Like it's moving back and forth. But it really, well, we can just use this as an example. I can't quite go to 7, but close. Like here, this is time 7. So the dot would be way up here if the graph continued like so. Does that make sense? I'd say that y coordinate's about, I don't know, about 180. So the particle is way over here at that time. Is that your question?
Yeah.
2 points. Anybody else? Cool. Okay. Next thing. let's start working through the packet a little bit. Oh, we'll start working through the packet. So, the first thing it says, use your calculator to plot the position and velocity of the particle for the time, so position and velocity for the time period 0 to 0.3 seconds. So I grab my calculator. Some may know this, some may not. Hit y equal. I don't want to see acceleration for now, so I just come down. I don't want to delete because I want to use it later. Highlight the equal sign and press enter. That turns off the acceleration. Question? Just wave, can you show it again? Okay, while we're here, I want to show something, tell a quick story. So, eyes on me. Look up, put your calculator down. Okay, look up for a second, Colin. 1/3 of the AP test will require your calculator. So I can look up for a second. 1 year I had a student come back and was very concerned. Like, she didn't know how to help, but she really was really worried about her friend. She said to me, my friend Amy, I don't remember her real name, she said, Mr. Smith, Amy, during the calculator section, she was crying. Like, I was working and I just kind of looked, she was sitting right kind of here. She just was in tears. And I couldn't do anything to help her. Found out later that what had happened was, when I talked to Amy, she was doing some sort of problem and something, she has no clue what went wrong with her calculator. But the calculator section of the test requires the calculator, and the proctors don't help. Like, you raise your hand, they're just like, sorry, you're on your own. The good news is, this girl I'm calling Amy, I honestly don't remember her real name, she was able to kind of calm herself and remember what I'm about to show you. Okay, like, at least I think this is what she probably fixed, found and been fixed. It's really common when you're entering graphs to accidentally end up on top of that plot symbol. And then accidentally you press enter. It turns on the plot, which is a statistical function we don't use. So then when you hit zoom fit to graph everything, it's just doing some calculations. You get that error message, okay? And I don't know for sure, but it's possible that this girl I'm calling Amy, that's what was happening. And so she's just like melting down because she's like, I've spent the whole year preparing for this test. Now my stupid calculator won't work. The good news is I'm showing you today so it doesn't happen to you. Okay? You get the error message, don't panic. Just y equal, highlight plot, press enter, turn it back off. That's it. Just wait if you need to show that again. Okay, other good news, she did recover and get a 4 on the test, so it turned out just fine, but just don't want that to happen to you. Another thing that you can do, let's stop that. If your calculator's having trouble and that doesn't fix it, highly recommend that you do a full reset. Just hit second. Don't reset your calculator now, but this is how you do it. Hit the memory key, which is down here above the plus. It's the plus key. Choose 7. Choose number 1, all RAM. And now I'm going to stop because I don't want to reset my calculator. And then choose number 2 to reset. That'll start you back over from scratch. Questions? Please.
Do you do that like after every problem, like these problems?
No, good question, Emma.
Like, when do you use that?
Only if you're working the calculator and something goes wrong. And you're like, I can't get the stupid thing to work. You know what I'm saying?
Yeah.
Yeah.
Okay.
So as long as everything's working, don't ever do that.
Okay.
It's just like, hey, something's gone wrong. It's just the last resort. You don't want to spend time, try this, try that. Just reset, start over. So good question. 2-1. Anybody else? Okay. Another thing I needed to show you, I forgot. Hit the mode button everyone wants to change this on an 84. If you have an Inspire, there's a setting that does the same thing. It's not exactly the same place. Change this to 3 and just leave it. The AP test requires that you use every answer from a calculator to be rounded to 3 decimals or more. Otherwise, they don't give you the point. So the easiest thing to do is set your calculator for 3 decimals and just leave it alone.
So should we be in radians?
Yes, every AP calculus question will require the calculator to be in radians. It doesn't really matter unless you're using a trig function, but we just leave it there, then we're in good shape. So. Cool. Questions? Oh, please.
We change our answers from auto to decimal too.
Oh, thank you, Brady. I prefer decimal just because it's fine to do the fraction thing. I just find that on the story problems that we work with, if the answer is as a decimal, I can usually do a better job of looking at my answer and saying, yeah, that's reasonable. If it comes out as a fraction, I'm kind of like, I don't even know what that means. So that's how I set up my calculator. Thank you, 2 points. Is down here. I set the answer to decimal, just my preference. So. Anybody else? Please.
Mine's not on sequential. Should it be on that? Mine's on this.
I actually don't know the difference. Do you know?
I don't know the difference. So
Yeah.
I would put it on sequential then.
Yeah, I really don't know, Timmy. Good question. I've never played with that. So. Oh, that's interesting. Now you got me curious. Got to try it. So here we were in the middle of, we turned off the acceleration, and then it said in the instructions to graph the window from 0 to 0.3. Is that correct? It's just on your worksheet there.
Definitely.
Thank you, Maddie. So 0, 0.3, and then zoom fit again. So this is sequential. Oh, it does it at the same time though. I'm a fan. I'm changing. I hate waiting.
Oh, yeah.
Like it's no slower.
I changed mine now to 1 at a time.
I've never done it the other way.
Oh,
Have you?
It's sequential
Yeah.
and single time.
That's a dumb feature. They should make the. Well, I guess they think it's fun to watch. I don't think it's fun to watch. Sorry.
Sometimes it might be nice to sometimes see one coming in, then the next one, and you can know this was Y1, this was Y2, Y3. Even though you can scroll through it, but
Oh, true.
it might be nice to know which one you have in Y1, Y2.
Really? No, good point. And probably better on the black and white. If you have a new color, colors kind of sort that out for you a bit. That's a good point. So yeah, that's the difference. Thank you, Timmy. I like saving time, so I'm going to go this way, but either way, it's your choice. So.
I want to see what it looks like this.
Anybody else? Sweet. 15 years. No one's ever pointed that out. Well done. Worthy of a ticket. Okay.
You made history, bro.
Yeah, the Timmy Woosley method. Your name will go down. Just give me a sign for the wall, Timmy, then we're all good. Hey, it's perfect. Timmy's tip. All right. We got Maria's mentality, and Amanda's advice. We just need Timmy's tip. We're all set. Sorry, it's really flying, but
That's okay.
it's all good. All right. So hands up. You have this on your screen. Show me. So get that to work. Yeah, so we went to. So on the worksheet it says set your window from 0 to 0.3. Turn off the acceleration, then zoom fit. So.
Acceleration is the third.
Acceleration we put into Y3, so. Oh, please.
So you turned off the acceleration, right, because it's a condition.
Yeah, and there's nothing special about that. 2 points, Janessa. I was just following the instructions. Yeah, it says, plot those two. It wouldn't hurt anything if you had the acceleration, I suppose, just to be easier to see. That's all. There you go. Okay, Jay? So show me hands if you have this on your screen. Show me hands. I'll pay. Show me hands. Don't ever take payment if you're not raising your hand. 2 points. Okay, cool. All right, here we go. Make sure you memorize this. This particular homework packet has a decent number of notes you have to get memorized. So make sure you memorize that velocity is the instantaneous rate of change of position. Keyword is instantaneous, meaning it's how fast the position is changing at any given instant. Emily?
I'm from a different job.
On this topic.
Oh, it's -4.
Oh, yeah.
Can you say that definition again?
Right here, it's in your notes. Velocity is defined as the instantaneous rate of change of position.
I know, but you said like a different way of saying it. It's like
Oh, I gotcha. It's the it's how much the position is changing at any given instant. Good question. 2 points. So that definition means, you know, how much is the position changing at any given instance? Please.
I can't figure out how to use my calculator.
No worries. Let me look, Sean.
Like squat, or you can play by yourself.
So the equal sign is the indicator of whether or not this function you've actually turned on. Right, we're trying to graph. So y1 is the position. That's the y2 is the velocity.
If I land this, you give me 5.
Graph this.
If you like die.
If I land this bottle point, you give me a ticket. If I don't, I'll go to If I land this, you give me a ticket. If I don't,
To get the window that I have on the screen, I've turned off. So I just want to see the position of velocity. So use your cursor to highlight that to this side right there. Just enter the track.
if I land this, you give me a ticket. If I don't, I'll give you a ticket.
Actually, remember that more because
You just have force. The other thing is, if your timer is running the old operating system, that's why you're getting so bring your calculator check that. Call me back. Hey, look out, thank you for your patience. With calculators, it always takes a little bit of time the first day just to make sure everybody's together. Questions, anybody else? Okay, cool. It says, what is the velocity of the particle at time equals 0? I want to show you two ways to find that. One way most people have used it for. The other way is typically new. You've never seen it, and you'll want to use it in the future. So your screen should look like this one here. So if I go to my calculator, the orange is the velocity. So one way to find the velocity at time 0 is to simply hit trace. The cursor, the calculator will tell you which function the cursor is using. So right now the cursor is on position. I want the cursor on velocity. So I simply use the up-down arrow to move the cursor. Questions? Then I tell the cursor where to go. I want to go to time equals 0, so I just type in 0. And press enter. The other number tells me, oh yeah, at time equals, remember, the graph is just a bunch of numbers. Time equals 0, velocity is -1. Question? Wade, you need me to do that again? Thomas?
So I have a question with when you go to y equals, why do you turn off the equal sign highlight on the last one?
Oh.
So I'm just a little confused on
No worries. The reason I did that is for this portion of the worksheet, we're just going to kind of be talking about position and velocity. And if I plot the acceleration, it makes the graph hard to see. Like I get this picture.
Yeah.
I just want to focus on position and velocity. So by turning off the equal sign, it makes it so acceleration is not plotted.
Oh, okay.
Is that what you meant?
Yeah.
2 points. Anybody else? Okay, back to here. So one way again to find the velocity at some time is just use trace. Get the cursor on the correct graph. Type 0. There's your velocity. Here's the new method most people haven't seen before, which in future problems I guarantee you will find useful. Go to the main screen, so second quit. Now, Allie, I don't think your calculator will do this, but try it and then just let me know, because I think you need the upgrade. Hit alpha and then trace, and you should get a menu. Oh. Yeah, see, always good to see something new, you know.
Where you click alpha then trace?
Alpha then trace. Did Allie do it?
It's not doing it.
The upgrade will fix that too. Alpha trace. Anybody else? Okay. I want to go find the velocity at time 0. the velocity is in y2. So I press 2, select y2, and then I use function notation. Parenthesis, 0, parenthesis. Press enter, there you go. So you have the same thing that Ali has. You have the right calculator, but the software inside is too old. So bring it to me after school, or your grandma. You can ask her, she's not sure how you do this. And then it takes like 5 minutes. Just the software. Calculator software. Anybody else? Does that make sense? Cool. Yeah, we'll use that in the future. It's pretty handy to be able to do that. So back to here. Okay, so we found the velocity of the particle at time equals 0 is -1 meter per second. Okay, I've mentioned from the start of the year that your success on May 4th is highly dependent upon having the right habits. One habit you must develop is every time on the AP test where you write down an answer, you have to include the units. Develop that habit. That way, on the problems where they give points for units, you don't accidentally forget. So they don't give points for every problem with units, but they give enough that you just don't want to forget. You don't have to have the units in your work, but in your final answer, you must have the units. So, or they really do take off the point. Question. Okay. This means right here. It says, what does that mean? X of 0 means the position of the particle at time equals 0. The position of the particle at time equals 0. So from the calculator, we can find that, of course. We can go back to the graph, hit trace, go to the position, make sure it's time 0. And in this case, the position is also 0. Yeah, the bell's going to ring, but hold on, I think so. So this is 0. There we go. Again, don't do the orange package, the old package. Just save it for when you come back on Tuesday. Good work. See ya. Good job.